Okay guys, so in this video we are going to discuss mensuration formula for 2D, 3D figures. So these are very simple formula, you already know it. So in this one lecture, we'll be covering all the formula for 2D and 3D figures in mensuration. So without any further ado, let's start. So first of all, we'll go for the 2D figures. 2D figures include squares, rectangles, circles. You already know it. It is just for the sake of completeness we are discussing. So if you have a square, if one side of the square is A, so square has equal sides, so area will be A square and perimeter is 4A. Rectangle, length and breadth. Okay, so area will be L into B and the perimeter will be 2 times L plus B. For circle, if you have a circle with radius R, then its area will be pi r square and the perimeter will be 2 pi r. Now if you are given a scalene triangle, then and let's say the sides are A, B and C, then its area will be calculated from this formula, root over S into S minus A into S minus B into S minus C, where S is the half of the perimeter. A plus B plus C is the total perimeter divided by 2 and perimeter is A plus B plus C. So simple things. Let's go for the isosceles triangle. For isosceles triangle, you can see the sides are A and B and the height is H. Then the area of the triangle will become half times B into H. B is this, H is the height, and obviously the perimeter will be 2 times A plus B. For equilateral triangle, all sides are equal and the area will be root 3 by 4 into side square, means A square, and the perimeter will be 3 times length of each side, 3A. Right angle triangle, you can see different types of triangles are shown here. So right angle triangle means one angle will be 90 degree and the formula will be half time base into height. You can consider this as base, this as height. So half time base into height will be the area of this right angle triangle, and perimeter obviously base plus height, and this is called hypotenuse. This length is called hypotenuse. So base plus height plus hypotenuse gives you the perimeter of the right angle triangle. Let's move on. Some other few more structures are there in 2D. Rhombus. For rhombus, you can see the diagonal lengths are D1 and D2. D1 and D2, and the area will become half of the multiplication of the diagonals to D1 and D2. And obviously, the rhombus perimeter will be 4 times the length of each side. Okay, 4 times the side. Parallelogram. If you consider the parallelogram, this is the breadth, this is the width, and this is the height, you can say. Then the area of the parallelogram will become B times H. B is this, H is this. And what about the perimeter? 2 times W plus B. W and B are shown here. This is W, you can see, and this is B. For trapezium, so ABCD is a trapezium and it has height H. Height is this perpendicular distance. So the area will become half times A plus B. A is this side and B is this side. So half into A plus B times the height H, and the perimeter will become A plus B plus C plus D. It's very simple. Now let's go to 3D figures. So in 3D figures, you know, we have the first one, cube. Cube has equal sides. So if the side length is A, then its volume will be A cube. Look, in 2D, in the case of 2D, we are interested in area and the perimeter. There is no volume thing in 2D, but in 3D figures, the extra or additional thing is coming into picture, that is the volume. So volume and curved surface area and the total surface area we have to consider. Okay, so if you consider, let's say, a cone in this way, so you see it has curved surface area, right, and this is plane surface area. So it will have 2 types of surface area. One is this curved surface area, another one is plane surface area, and that will make the total surface area. Okay, that is why you have given into 2 columns, curved surface area and total surface area. For cube, there is no curved surface area, so total surface area is the plane surface area, that is 6 times the area of one side, that is A square, 6A square. For cuboid, length, breadth, height, length with height, whatever you can want to say, and the total surface area will be, if you consider this as L, this as W, and this is h. So this area will be h into w, this area will be L into h. In this way, because two sides are there, two similar sides are there, so that is why a multiplication factor of 2 is there. 2 times LH plus LW plus WH. If you consider the sphere, and if it has the radius r, then its volume will be 4/3 pi r cube. The total curved surface area is 4 pi r square, and there is no plane surface area, so the total surface area is the plane surface area, sorry, curved surface area, that is 4 pi r square. Okay, I think this is the last one. For hemisphere is half of the sphere, so the volume will be 2/3 pi r cube, so 4/3 pi r cube by 2, and the curved surface area, you can see the total curved surface area was 4 pi r square for a full sphere. For a hemisphere, means half sphere, it will be 2 pi r square. This is the curved surface area. You can see the plane surface area is also there, which is pi r square. So total 2 pi r square plus pi r square, that becomes 3 pi r square. So that is why the total surface area of a hemisphere is 3 pi r square. If you consider the cylinder which has radius r and height h, the total volume will be pi r square into h. Pi r square is the base area, and if you multiply the base area with the height of the cylinder, that gives you the volume of the cylinder, pi r square h. And you see it has plane surface, these are the plane surface, and it also has the curved surface, So you can see the curved surface is 2 pi rh, and the plane surface, you can see pi r square on the bottom, pi r square on the top. So 2 pi r square, that is why the total surface area is 2 pi rh plus 2 pi r square, curved surface area and the plane surface area. If you consider the cone, the volume formula is 1/3 pi r square h. This is the radius r, height h, and this is the slant height L. And obviously you can figure out that L is nothing but root over h square plus r square. Okay, so volume is 1/3 pi r square, and that area of the curved surface means, if you consider this one, this is the area of the curved surface, that is pi r L. Okay, and L is this root over h square plus r square, and the total surface area, you see the pi L is the total curved surface area, pi r square is the plane surface area. So that is why the total surface area becomes pi r square plus pi r L. So I think this lecture will help you to tackle problems from mensuration. So in one lecture we have covered all the necessary formula for 2D and 3D figures. Thank you very much. See you in the next lecture.